So the last couple of class periods, we had Thursday, which, it's the day before a long weekend. People aren't going to be super attentive, just in my experience, right? And then yesterday was just weird, right? I not coming in and teaching, I didn't have everything that I wanted, so, I rushed through it. If there's one thing that I needed you to remember from yesterday, and I'll ask about that in just a little bit, but I'm basically, today is going to be a catch-up day where I'm going to review kind of bits and pieces of review from what we did Thursday and what we did yesterday. All right, so if you're a little fuzzy about those, you're going to get a chance to practice those. All right, and so what we talked about Thursday was composition of functions. What we talked about yesterday was the idea of an inverse. And so how do I start today? I ask you to grab a parabola, which doesn't seem to have anything at all to do with any of those, right? But this wasn't too hard to graph, was it? All right, we got our parabola. What do we do? Back 1 up 3. And so when we graph it, okay, so this is back 1 up 3, and we plot some points. Everybody get a picture that looks kind of like this? Everybody okay with that? Perfect. Okay. So, and actually, while I'm at it, what I'd like to do here, let's plot new function. I actually want to plot this function, so that's going to be, whoops. So I want to do, is that x plus 1 squared plus 3, click OK. And yay, I have my little picture. All right, so graphing this wasn't that bad. All right, so now let's try to connect this to finding inverses. What was the one thing you were supposed to remember from yesterday when anytime any math teacher asked about an inverse? What do? Perfect, right? Right? That is the one thing. Anytime a teacher asks about an inverse, your first idea, you say, I had a crazy guy last year that kept telling me it means swap x's and y's. I don't even know what that means, but I know if a teacher says inverses, I know I'm swapping x's and y's. Right? Right? Now, so if this is the function, right? Right? If this is my function, I want a graph of the inverse. And how you find a graph of the inverse, given a picture, first you want to identify nice points, right? And nice points are like this dot, this dot, this dot, this dot, and this dot, right? They cross at nice spots. They don't cross somewhere in the middle. Technically, they're called a lattice point, but that's technical terms. I don't want to talk about that. We have nice points. So what I want you to do is let's think about these dots. So like this dot is, what's that, -3, 7. Actually, I should color code this. So this is -3, 7. This point is -2, 4. This point is -1, 3. This is 0, 4. Let's see, that's 1, 7. So if I want my inverse, guess what I do? So if I have a list of, so what I do is I get a list of points, and this is the points on my function. How do I find the points on the inverse? You swap x's and y's. Everybody okay with that? So I'm going to swap x's and y's. So this -3, 7 now becomes 7, -3. This -2, 4 now becomes 4, -2. Okay. Then I get a 3, -1. Then I get a 4, 0. And then I get a 7, 1. Everybody okay? Everybody okay with this? We just swapped x's and y's? So if you're given a graph, identify the nice dots, right? Swap them, right? Swap x's and y's. So these are the dots on our inverse. And now I'm going to plot it. Now, here's kind of the trick. The thing you got to be a little careful about when you plot, particularly when you're plotting the inverse, go in order. Like, notice how I got this, these points went in order, right? And we're going to plot these points in order. So we're going to plot the point 7, -3. So this is 7, -3. This is 4, -2. Is that 3, -1? 4, 0, and then 7, 1. And I end up with this thing. All right, so we have a parabola, now we have a sideways parabola. Does that picture make sense? Is everybody with me so far? All right. What have we done? Well, I gave you a function. I said plot some dots. Get some dots, swap x's and y's. And now connect them and make sure you kind of connect them this way. Well, so now I've got some questions. And my first question is about this thing. If I look at this, my original parabola, is this a function? Okay. Now, how do you determine if something's a function or not? Remember that vertical line test, right? Is everybody okay? Right. I know I haven't done a whole lot about functions. And you're having to go back a couple of years in Algebra 1. But everybody remember the vertical line test? Right? And the vertical line test basically says if it only crosses once, it's a function. I don't know if you remember, usually they have some sort of exercise where they have these really weird graphs and you draw a vertical line, and if it ever crosses more than once, it's not a function, right? But this one we draw it, it's a function, right? Okay. What about this red thing? Is this a function? Okay. Everybody see this is clearly not a function. So what we have is a case where here's a function, right? So here's f and here's f inverse. F is a function, but f inverse isn't, right? Right? So kind of the obvious question here is, if you have a graph of f, is the inverse of f going to be a function? No, not necessarily, right? In fact, we have an example here, right? Here's a graph, right? Its inverse is not. Oh, also, when we're talking about a function and its inverse, there's this, what I tried to draw on, by hand yesterday and just did an awful job. There's this idea that if you draw the line y equals x, can you see that the inverse doesn't change the shape at all? We have a parabola, we have the exact same shape parabola as the inverse. And can you see that there's like a reflection? There's this y equals x. You can see there's a mirror image over here. This is what I tried to draw, on my makeshift teaching apparatus at home, right? And I really needed this. It's a lot easier. Can I see that part? Well, let's talk about the conditions. I want something to be a function. If I have, I'd like the inverse to be a function, and I'd like to know if the inverse is a function or not before I actually find the inverse. That's a lot of words, right? But so we know that if a vertical asymptote, if I do the vertical line test, we can kind of see if I draw a vertical line here, it crosses at two spots. They have something, it's called the horizontal line test. And the horizontal line test is, if you look at the original problem, if you can draw a horizontal line that crosses in two spots, then you know the inverse isn't going to be a function, which to me is kind of silly because you can think about it as this vertical line before it was flipped was a horizontal line. Can you kind of see that? And so anytime you can draw a horizontal line, that means the inverse isn't going to be a function. But actually, I don't care so much about when it's not going to be. I'd like to know, what does the graph, yes?
Sorry, I didn't fully understand the horizontal line thing, so if it's between 2 points, what do you mean by that?
So you're okay this isn't a function, right?
Yeah.
Think about, and if you can think about the inverse as something that's been flipped.
Yeah.
So if you take this image and pre-flip it, you get this, right?
Yeah.
So can you see that a vertical line before it's flipped is a horizontal line?
Yes.
So they have something that every textbook, they call it a horizontal line test. And they're saying, if you have a function and you draw a horizontal line and it crosses at more than one spot, that means when you flip it, it's not going to be a function. Basically, this is the vertical line before it's flipped.
Yeah, I understand that.
Yeah.
Isn't crossing through any parabola going to be?
Yeah, but no parabola. If you take any parabola and you flip it, it's not going to be a function.
Yeah.
All right. So now my question is, what does your function have to look like so the inverse is also a function? Wait, do you understand the question? All right. There's it's a theoretical thing. I consider it like a perfect math question. Requires no computation but an awful lot of thought, right? What is the shape, like what's an important feature of a function that the function and its inverse are both functions? Yes?
I don't wanna sound dumb though, it's not.
No, say, I don't think you're going to sound dumb. In fact, I'm fairly certain you're not.
A circle?
Well, the problem is a circle a function?
No.
Okay. It needs to start with a function.
Yes.
Okay. Yeah.
A straight line.
Okay, that's a good start. So what Sean said, he said, I'm just going to draw a straight line. Here, I'm going to delete this because I'm not going to need it now. It's getting in the way. So Sanj said, I'm just going to draw a straight line, right? And if I reflect it, actually let me draw it this way. And if I reflect it, hey, that's a function, right? So a straight line, for the most part, does. Actually, it doesn't have to be straight. Okay? Here's the defining feature. It has to either be always increasing or always decreasing. For example, if I do this, that's a function. And if I flip it, good grief, how do I draw this? You see that's also a function, right? So it doesn't have to be a straight line. What it has to be is either always increasing or always decreasing. If you notice, does this pass the horizontal line test? You see if I draw horizontal lines, it only crosses once. And when you flip it, the vertical lines only cross once, right? So the trick is, if a function is either always increasing or always decreasing, here's one that's always decreasing. So let's say I draw an always decreasing one that looks, I don't know, something like that. All right? So that's always decreasing, and it turns out the inverse of this, oh, that's an absolutely awful example. Let me try that again. Let's do this. This is decreasing, and if I draw, let's see, the flip of it, it's still a function. So the idea is, if you have a function, you have a function and you have its inverse. They're both, a graph and its inverse are both functions, as long as they're either both always going up or always going down. All right. So there's that. All right. So we've got our picture and everything else. So now I'd actually like to compute the inverse. So how do we go about computing the inverse? Given a function, how do you find the inverse? So the first thing you do, remember f of x is just a fancy y. So if f of x is just a fancy y, that's y is equal to x plus 1 squared plus 3. And then what is the overarching theme for finding inverses? Swap x's and y's, meaning every see an x, you put a y, every see a y, you put an x. And so that's going to give me x is equal to y plus 1 squared plus 3. And now our job is to solve. Once you've swapped x's and y's, now your job is to solve for y. So what do we do to solve for y? What do we do to get y by itself? Subtract 3. Right? So that's going to give me an x minus 3 is equal to y plus 1 squared. All right. Now what? Remember, we're trying to get y by itself. What do we do? Take the square root of both sides. So far, so good? I'm going to put a star here because something weird's going on. So now that gives me the square root of x minus 3 is equal to y plus 1. So to get y by itself, what do I need to do? Subtract 1. And so now I have, if I subtract 1 from both sides, this is going to give me the square root of x minus 3 minus 1. Is everybody okay? That's my inverse? I guess technically I should say this is f inverse of x. Well, that's interesting. All right, so there's our original function. I'm fine with that. Now I want to graph. Plot a new function, and my new function is going to be, let's see, square root of x minus 3 plus minus 1 so I've graphed it. Wait, something's missing. Can everybody agree that something's missing? Like we tried to find the inverse, didn't we? Right? So when we tried to find the inverse, here was our function. We graphed the inverse earlier. We got the full sideways parabola, right? I don't get the full sideways parabola. Okay. Here's why. First of all, is this a function? Is what's graphed a function? Yeah, so we got a function, yay, right? And we got our inverse as a function. So, what's going on here? Well, remember I said something weird, something tricky is going on here? When we were solving quadratic equations, anytime you take the square root of both sides, what did you need to do? If I give you x squared is equal to 16 and you solve this, when you take the square root of both sides, you get x equals what? Plus or minus 4, right? Do you remember anytime you take the square root, you got to put plus or minus? Or do you remember it now? Same thing works over here. When I take the square root of both sides, technically this is plus or minus. Right? Since that's plus or minus, this square root x minus 3 minus 1, that's the top half. If I were to also graph negative the square root of x minus 3 minus 1, what do you think that's going to give me? I think that's going to give me the bottom half. So I'm going to graph it. So I'm going to plot negative square root of x minus 3 minus. You see how I got the bottom half now? So we get our full thing. So when you're solving, right, this gives you your plus or minus. Of course, this isn't a function because it fails, but there's actually two parts. There's this top part and there's the bottom part. All right, so here is